Okay, so I want to welcome you to adding and subtracting rational expressions with different denominators. Emphasis on different. There was a previous video where we worked with common denominators. In this case, we're going to work with different. So here are the steps to find the LCD of the rational expression. We write each rational expression as an equivalent expression whose denominator is the LCD. Add or subtract the numerators and place over the common denominator, and then simplify if necessary. So getting started, we simplify the rational expression of b over 4 minus 2a over 8. Okay, so we want to identify our LCD, and it's a number that both of these can go into. 8 can go into itself, and 4 can go into 8. So our at least common denominator in this case will be 8. So for this first one, b over 4, how do we get the denominator to be 8? We multiply by the fraction of 1 as 2 over 2. Multiplying, you're going to get 2b over 8. Now just bringing down the rest of the problem of 2a over 8. If you notice, the 8 is already the least common denominator, so you can bring it on down. And if you were to simplify, you would have 2b minus the quantity of 2a over our least common denominator of 8. And you could just simply take away the parentheses, leaving you with 2b minus 2a over 8. If you wanted to, you could take it a step farther, seeing that you can pull out a 2 on top and bottom. So pulling a 2 out on top, you're going to be left with 2 times the quantity b minus a. And on bottom, you can think of 8 as the product of 2 and 4. So those 2's would cancel out, just leaving you with the expression b minus a over 4. Okay, looking at our next example, we have 3 over 10x squared plus x over 25x. So we need to identify our LCD. Will 10 and 25 one go into the other? No. But if you know, 50 will have 10 going into it evenly and 25 going into it evenly. So we can work with 50. Now with our variables of y, we need to identify the largest, which is 2, an exponent of 2. So the largest exponent will be in our LCD. So now we have to think to ourselves, how do we get the 3 over 10x squared to look like the exponent of 50x squared? Well, to do that, you just have to multiply by 5 on both sides, or excuse me, as a fraction of 1. So that would make the 10 become 50, and then you're just left with your variable of x squared. So you have 3 times 5 on top. On the bottom we have 5 times 10 squared. Okay, and if we simplify on further down, we have 3 times 5 is 15 over 5 times 10x squared is left with 50x squared. Okay, over here we have 7 over 25x. To make 25x look like 50x squared on the bottom, we want to multiply by 2 to make the 25 become 50, and multiply by x to make the x squared. We would multiply on the bottom, we multiply on top to make the fraction of 1. Multiplying across, on top we get 7 times 2x over 25x times 2x. During our multiplication, we have 14x on top. After doing multiplication on bottom, we're going to have our denominator of 50x squared. Let's bring our pieces together now. So we have 15 plus 14x over 50x squared. Alright, noticing that we cannot take it any further because 15 does not have an x, we know that this is our simplified expression. Okay, looking at number 4, we see that, first of all, that's a glitch and that x should be an m. So what I would identify first is that the LCD what it should be. So we have m minus 3, and if we want to flip this one around, we could have minus m plus 3. Well, note, if we were to factor out a negative 1, so we'd have m minus 3, we would have a similar looking denominator. All we'd have to do is have negative 1 times the quantity m minus 3 as the LCD. So let's now take what we have, what we've gathered, and rewrite it as a simplified term. So that is what it really looks like using our work from above. Now we want the LCD to have a negative 1 involved. And the way to do that would make sure that we multiply negative 1 over negative 1 times this original quantity, 7 over m minus 3, because it has the m minus 3 but it lacks the negative 1, okay, and minus 9 over negative 1 times m minus 3, and we don't need to multiply by anything because we have our least common denominator. Simplifying across, we have negative 1 times 7 over negative 1 times the quantity m minus 3 minus 9 over negative 1 times m minus 3. Okay, let's simplify. We have negative 7 minus 9, because we just bring them together, and negative 1 times m minus 3. Okay, doing our last step, negative 7 minus 9 is going to give us a negative 16 on top, with our negative 1 times the quantity m minus 3 on bottom. Okay, notice that these negatives right here can cancel out, just giving us a positive 16 over what eventually can become an m minus 3. Okay, if we look at our next problem, we have 1 plus n over n plus 2. And the fun thing about 1 is that it can be written as anything over itself, like we've done in the past few examples. So the least common denominator is actually going to be n plus 2. And to convert that, we want to make the 1 to be n plus 2 on the bottom, and to make that fraction reduced to 1, we just write the same thing on top. So we have 1 becoming the fraction of n plus 2 over n plus 2. And then just simply drag down our n plus 2 on top. So now let's just bring everything together of n plus 2 plus the n on the other side all over our common denominator of n plus 2. So everything that has something in common, we're going to box it in a square. So we're going to have 2n plus 2 over n plus 2. And that is as far as we can take the problem, so it is simplified. Okay, and with number 5, the most important thing you want to look at doing first is factoring the denominators. So with this first, we're going to open up our parentheses with x inside, and then plus 1 for each one, because 1 times 1 gives us 1, and then if you add 1 and 1, that would give us the 2 found in the middle. Okay, and for this last piece, we actually have x plus 1 and x minus 1. So all we want to do for this problem is just to identify what the LCD would be. So the LCD, we know that both pieces would have the x plus 1 for certain. That would be a common term for both. And then also would have to add the extra x plus 1 and the extra x minus 1 and that would be our LCD. And that's as far as we're going to take that problem, because it would be very long and lengthy and really, honestly, not worth it to solve this, because it would take so much energy and time.